Good day, viewers. You are welcome back to Tindanious Maths and Science YouTube channel. We are still treating complex numbers, okay? And in our previous videos, we learned that there are three ways we can represent complex numbers. And number one is the rectangular coordinate or the Cartesian form, okay? The rectangular form or the Cartesian form. The second one is the polar form or the circular form. And the last one is the Euler's form or the exponential form. And we've learned on how to convert one complex number, that's from the rectangular form to polar and the exponential form. So if you are new here, kindly visit my previous lectures where I've dealt with that. In today's YouTube video session, we are going to look at how we can multiply complex numbers in the polar form. So we are going to learn how to prove that. So we learned that in the polar form, the complex number z, this way is equal to what? R multiplying, we have what? Cos theta plus I sine what? Sine theta. Is that also where R is represents your modulus and the theta or the angles here represents what? Your argument. This represents the real part and this represents what? Your imaginary part. Whereas the z represents your complex numbers. So let's look at the proof over here. So if you have complex number z is equal to this, then I will say let's say z1 is equal to r1, then I have cos theta 1, then plus I sine theta 1, this way. Also, can say complex number 2 is equal to what? R2 multiplying cos of the argument of 2, that's theta 2, plus I sine theta 2, this way. Because I'm doing multiplication of these complex numbers in the polar form, so I can say that z1 multiplying z2 is equal to what? You multiply this and that. That also r1 by r2 gives what? r1 r2. Then I have this cos theta 1 plus I sine theta 1 multiplying this cos theta 2 plus I sine theta 2. You can just multiply it this way, but step by step is key in mathematics. So we have z1, z2 is equal to r1, then r2. Then this cos theta 1 multiplies the expression over here. So I have cos theta 1 multiplying this cos theta 2, then plus I sine theta 2. Then I have plus I sine theta 1 also multiplying everything here. Cos theta 2 plus I sine theta 2. So I will have z1, z2 is equal to r1, then r2. Cos theta 1 by cos theta 2 gives what? Cos theta 1 cos theta 2. Then plus cos theta 1 by I sine theta 2 gives cos theta 1, then I have what? I sine theta 2. Then I have plus I sine theta 1 by this gives what? I sine theta 1, then cos theta 2. Then I sine 1 times I sine 2 gives what? Plus I by I gives I squared, right? So I have I squared. Then sine theta 1 by sine theta 2 gives sine theta 1 sine theta 2. As simple as that. Okay, so let's do rearrangement over here. Okay, so I have r1, r2, of course, which is equal to z1, z2. Then I have cos theta 1, cos theta 2. Then I have plus I sine theta 2, cos theta 1. Then plus I have I sine theta 1, cos theta 2. Then plus I squared sine theta 1 sine theta 2. Then we know that I squared is equal to what? -1. If this is your first time, kindly visit my previous lectures on Introduction to Complex Numbers. In fact, I've explained this into details. Okay, everything is well explained. So we can just simply substitute I squared, which is equal to -1, into this. You get it? Then we proceed. So as a result of that, I'll say r1, r2. I have cos theta 1 cos theta 2 plus I sine theta 2 cos theta 1 plus I sine theta 1 cos theta 2. Then here I have what? Plus, then I squared is what? Negative. So I have -1. Okay. Then I have sine theta 1 sine theta 2. So if that's the case, then this is the same as what? Negative sine theta 1 sine theta 2. By rearrangement, I can say that r1, r2, I have cos theta 1 cos theta 2, then minus sine theta 1 sine theta 2. So I'm done with this and I'm done with that. So I'll pick this and that. Then I have plus I sine theta 2 cos theta 1 plus I sine theta 1 cos theta 2. For want of space, let's move on to this side. This is what we have. So I is here and I is here. Since I is common, I'll do factorization. So I'll factor I out. So I have r1, r2, then I have cos theta 1 cos theta 2 minus sine theta 1 sine theta 2, then plus I take the common term out, which is I open brackets. I have sine θ2 cos θ1, then plus I is already there, so I have sine θ1, then I have cos θ2. Viewers, let's do a little bit of recap on the trigonometry identities, okay? So now, when we have, let's say, have cos of A plus B. In trigonometry, we know that this is the same as what? When you expand this, we get cos A cos B, then minus sine A, then sine what? Sine B. Also, know that sine A plus B is the same as we have what? We have either sine A cos B, then plus sine B cos A. This is a trait identity, okay? So you have to know this. So I can say that this is my A, this is my B, θ1 is A, θ2 is B. θ2 here is B, I have A here, and I have what? My B. So I'll just do direct substitution, okay? So I'll have r1, r2, I have cos A cos B, or cos θ1 cos θ2. Okay, so let's do this way. Let's say this is θ1, θ2. Here my A represents my θ1, my B here represents, let's say, the θ2. So here will be θ1, this is θ2, to avoid confusion, okay? This is θ1, θ2, θ1, θ2, θ2, then θ1. So as a result of that, I can now say that cos θ1, cos θ2 minus sine θ1, sine θ2 is the same as what? So you come here, realize that the whole of this is the same as this. You get that, which is equivalent to this. So I can say that this whole expression, okay, is the same as cos. Okay, so we have, so the whole of this is the same as this, okay? There's it. Then I have plus, so plus I, then the whole of this is the same as what? It's the same as this. Because I have sine θ1 here. You get it that way. I have sine θ1 here, cos θ2, cos θ2 in that regard. So the whole of this is the same as that. I can say I, then I have sine θ1, okay, θ1, then plus B, and the B here is what? My θ2. This is the proof. So we can conclude by saying that if you want to multiply two complex numbers in the polar form, first of all, you have to multiply their modulus, okay? So r1, then r2. Afterwards, then you add what? The argument. So this plus that for the cos, then plus I, Then for the sign, you also add their what? Their argument. So this is multiplying, so you multiply their modulus. Then this side, you add their reference angle or their argument. As simple as that. Viewers, this is the end of the tutorials. I'll bring you questions in order to appreciate the proof of multiplication of complex numbers in their polar or circular form. Remember to always subscribe, share, like and comment for interesting videos and updates. Bye.